Hi there, Mrs. Hurst here. We're going to talk about 7.2 similar figures this time. We're going to talk about similar triangles and similar other shapes as well. First thing you need to know is this guy right here is the symbol for similar. It's just like congruent but without the equal sign underneath of it. When we're looking at similar figures, you need to know that angles are congruent. So we can match them up just like we have in congruent figures, but the sides this time are proportional. They break down into a scale factor or a simplified ratio between the side lengths. Let's look at an example. In this case, we're going to write down, just like we did with congruent figures, but we're going to write down our congruent angles, and then we're going to come up with a statement of proportionality to represent the sides. First things first though, this you've done before. These are my congruent angles, and I just used the similarity statement to come up with what goes together. Just like we've done before, first position goes with first position, second with second, third with third, etc. Okay? So now how do we come up with a statement of proportionality? We can either use the figure, the similarity statement, or we can just look at the sides. I know from A to B has to go with D to E, and I'm confirming that by looking at my similarity statement. So I'm going to write that as a ratio AB over DE. And since we're talking about their measures, I'm not going to include the bar notation over top of it. This is equal to every other ratio we're going to come up with. BC, so here's BC, going with EF in the second triangle. So since I started in triangle ABC, I'm going to keep that on top, BC over EF. And this is going to equal my third set of sides, CA over FD. Okay? And you could write this backwards. It doesn't have to be CA. You could write AC and DF, but we want to make sure that they do correspond. So this is my statement of proportionality.
All right, so we're going to actually determine if they are similar, because not all triangles or figures are similar, but we're going to check for two different things. So Miss Hurst used her artistic ability to draw you a little guy to remind you what you have to check for. You first have to check, are all the angles congruent, and then you got to check if the sides are proportional. So let's take a look at these two triangles. First off, let's look at the angles. We have angle A is congruent to angle F because they're both 90 degrees, represented by the little box. We also see that B and D have one arc, so we know angle B is congruent to angle D. And third, angle C and angle E both have two arcs, so they are congruent, so angle C is congruent to angle E. So yes, first off, we are checking all the angles are congruent. So let's check if the sides are proportional. We'll do this another color. So side AB, which is 3, should match with side FD, which is 6, which should equal the other two sides. AC, which is 4, is in proportional with FE, which is 8. And lastly, side BC, which is 5, and that's in proportion with side DE, which is 10. So now that you wrote it, you have to take a look. Are they proportional? So when we simplify all this, 3 over 6 simplifies to 1/2, 4 over 8 is 1/2, and 5 over 10 is 1/2. Since they all simplify to a scale factor, okay, and I just notate that as FF is 1/2, then yes, these are similar. Okay, and it says if they are, write a similarity statement and find the scale factor. So scale factor is 1/2, or 1 to 2. And I'm going to say triangle ABC is similar to triangle, and make sure the letters and the angles match up, FDE. So I've now answered the question with a similarity statement and a scale factor.
If you guys look right here, and what you did first, coming up with the congruent angles, you can just read it down. Here's A, B, C, so we're going to write the other triangle as F, D, E. So that can help you out coming up with your similarity statement. All right, so these polygons are similar as indicated, so we're telling you they're similar. So now we want to be able to find the value of x. The first thing I'm going to do is figure out, well, okay, how do I write the proportion? What do I do? I've got ST, so I want to figure out what does ST go with, and looking at the other side, we've got PQ. So I can set that up. ST goes to PQ. Just like in my other part of this, I need to include x, which is PR. P to R has to be S to U. So SU on top, PR on the bottom, but that way I'm sure to include X, which is what we're looking for. So now I want to replace this with numbers. So we get 6 is to 4, just like 12 is to X. Cross multiply and solve this. So we have 6X. I'm going to go ahead and keep working over here. Equals 48. So X is therefore 8. And that's the only thing they're looking for is the value of X.
All right, so there, right now it doesn't say, but I'm going to tell you that these two shapes are similar, okay? So since they are similar, we can set up some proportions. But what I suggest everyone to do, anytime the shapes or the figures, triangles, whatever you're given are overlapping, to separate them. So what I'm going to do is draw this little blue guy, the small one, off to the side. Okay, and we're listing the sides Y, Z, 10, and X. And then the larger figure, I'm going to highlight in red, and we're going to draw that also on the side. Okay, because now that they're separated, the blue is similar to the red, and let's fill on the side. 16, 12, and let's take a look here. This whole side length here includes the 10 plus the 14 to give me 24 is this bottom part. So sometimes if you don't separate and see that you have to add together, you're going to use the wrong number. And lastly on this side is 15. So we're solving for X, Y, and Z. So we're going to set up 3 different proportions. We'll do X together and then I'll have you guys pause and do Y and Z on your own. So X matches with the side length 15. Okay, so I'm going to put X over 15 equal to, and the only other sides that actually match up that have numbers, if you look here, Y and Z match with 16 and 12, but we're solving for X, so we can't use Y or Z, so we're actually going to use 10 and 24. So X over 15 equals 10 to 24. And that's our proportion to solve. When you cross multiply, you should get 24X equals 150, and then once you divide, you'll end up getting X to equal 6.25. Hopefully by now you're okay with seeing decimals because they get those all the time. So what I would like you guys to do is pause and see if you can solve for Y and Z.
You're going to need to use 10 over 24 again, so that way just in case you made an error with any of your other calculations, you're still using the provided information.
All right, so here are the answers. Hopefully you got Y to equal 6.6 repeating, or if you want to round that to the nearest hundredth, it's 6.67, and Z is 5.
Okay, so word problems. Usually these are intimidating, but they don't need to be. We're going to take it one sentence at a time. The sides of a triangle have lengths 3, 5, and 7. Okay, they said these are the sides of a triangle, so I'm going to draw myself a triangle. I'm going to call this side 3, this side 5, and 7. The first sentence is now a visual image. In a similar triangle, so I know I've got another triangle over here, okay, and I'm going to draw it facing the same way. So since 3 is my shortest side, this is going to be my shortest side over here. The shortest side of this similar triangle has length x minus 3. The longest side has length x plus 5. So 7 is my longest side over here. I'm going to put my longest side in the same position, x plus 5. Now we just need to set up a proportion to solve for x. So I don't need 5. He doesn't go with anything that's on the triangle. We're going to use 3 and compare that to x minus 3 equals 7 compared to x plus 5. Remember when you're cross multiplying with variables that you want to use distributive properties, so 3 times x plus 5 is equal to 7 times the quantity of x minus 3. Okay, so if we go ahead and work this out, you guys have time to do this while I'm talking right now. You should end up with x equals 9. Okay, so always read the information first. Draw yourself a picture. It's usually the most helpful strategy.
All right, so we're going to use this given information to answer 3 different questions. The first one is, what is the scale factor? The second one talks about the perimeters. And the third one talks about the ratio of the perimeters, because we're going to do this before we get into 2 other problems. So remember, scale factor is the simplified side length ratio. Well, you're already told that they're similar, the 2 quadrilaterals. So really, if you pick the smallest side length and match it up with the smallest or the shortest side length. You can set up your proportion. Okay, so we're going to use 4 over 6. If you did 6 over 9 or 8 over 12, you'd still get the same scale factor since they're similar. But 4 over 6 simplifies to a scale factor of 2 to 3 or 2/3. So that's what our scale factor is going to be. Now, we're going to figure out what the perimeters of the two quadrilaterals are. So remember, to find a perimeter, you can just add up all the sides. So 4 plus 6 plus 6 plus 8 gives you the perimeter of the first one to be, what is that, 24? Okay? And then if we do the perimeter of the other, just adding up 6 plus 9 plus 9 plus 12, you get, oops, I didn't do this math before I started.
What am I doing? I think 36.
36, sorry.
So 15 and 9.
Yeah. All right.
Is it 30?
So the perimeters, oh, sorry, I wrote that as a ratio, fraction. So the perimeter of the one is 24, perimeter of the other one is 36, okay? And it asks for what is the ratio of the perimeters, which I started answering is 24 over 36. When you simplify that, you should get 2 over 3. What is 2 over 3? Our scale factor. So what we've just found out is actually the scale factor is equal, so SF, like I said I notate, is equal to PR, which represents the perimeter ratio. So you can set up the scale factor equal to the ratio of the perimeters every time, no matter what, as long as it's similar. Okay? So let's look at this problem here. It says the lengths of the sides of the quadrilateral 4, 8, 8, 10. The length of the longest side of a similar quadrilateral is 15. What is the perimeter of the quadrilateral? We're trying to find the perimeter of the other one. We actually have the perimeter of this triangle here. So we can add those up, and the perimeter of that triangle is 30. So I'm going to use that within our ratio. It says that the length of the longest side of this one was 15. So the longest side of this quadrilateral is 10. So that's what I'm going to use in my proportion, my scale factor. 10 over 15 should equal the perimeter of the first one, 30, over the perimeter of the other one, x, which we need to find. So when we cross multiply that, you should get x equal 45, which represents the perimeter of the other quadrilateral. Okay? Let's try another one.
All right, this word corresponding, we've seen it when we're talking about angles and transversals. That means they're in the same position. This is the same kind of thing. When I'm setting up a ratio, that's what we've been doing. Smallest to smallest, longest to longest, they're corresponding. So I don't need to worry about which ones we're dealing with. The corresponding sides of two similar triangles are 5 and 8. So that right there is the ratio, 5 to 8. If the perimeter of the smaller triangle, well, they didn't tell us which one is smaller, but 5 is definitely smaller than 8 is. So I'm going to put that information on top. Smaller triangle has a perimeter of 30. So what is the perimeter of the larger triangle? You can call that X or you can call it P. And when we cross multiply for this, we get that the perimeter of the larger triangle, or X, is 48. All right, there are 3 questions here for you guys to bring to class tomorrow. They are your challenge questions. We'll talk about them in our groups. So make sure you copy them down, work them out, so that you have a good solid discussion with your group mates tomorrow.